Hey guys, and welcome to this lesson on solving compound inequalities. So previously, we learned some skills that we're basically just going to put together now to solve these sorts of inequalities. And those skills were, well, previously we learned how to take an individual inequality like 4d minus 7 is less than 8 plus d, and we learned how to solve it, how to kind of manipulate it and use some calculations to isolate d and then graph it on a number line. Or the same thing with this individual inequality or any of the other ones you saw. Another skill we learned was how to handle compound inequalities, where we had two inequalities at the same time interacting with one another with either an and or an or in between them. But the difference was before, those compound inequalities involved really simple inequalities that kind of had already been solved for us. So now we're just going to put those two together to solve these sorts of compound inequalities where, again, we've got two individual inequalities interacting with each other with and or, but we're just going to have to put in the work to simplify these all the way down to their simplest form. And so that's going to be our general strategy whenever we're faced with this kind of compound inequality. First things first, let's solve this guy on its own, and let's solve this guy on its own. So starting with 4d minus 7 is less than 8 plus d. I don't know, first thing I do is probably add 7 to both sides. We end up with, I hope I have enough room here, 4d is less than 15 plus d. Let's go ahead and subtract d from both sides. We end up with 3d is less than 15. We'll divide by 3, and we end up with d is less than 5. And let's just kind of leave that on its own for right now. For the second inequality, I think the first thing we're going to want to do is subtract 8 from both sides. And let's see, we're going to end up with negative 5d is greater than or equal to negative 10. When we divide by negative 5, got to remember that that inequality is going to switch directions. I always like to make a little arrow to remind myself. It's going to switch directions. D is less than or equal to 2. So that's the first step that I would suggest is just solve each of them individually. And now we are left with exactly the same type of problem we had in our last lesson. We've got the compound inequality, d is less than 5 and d is less than or equal to 2. So the next thing I would do is I would graph each of these individually. Now it's lucky for us because we have colors when we're working on an iPad, but one suggestion I have, this is kind of stylistic, is I'm going to do this inequality first, so here's 5. And I would suggest making nice long arrows. No reason to keep our arrows short. And I'm going to do the d is less than or equal to 2 in a different color. This one's going to be in green. And what I would suggest also is when you have multiple inequalities on one set of axes, make the arrows kind of right on top of one another, or at least different heights, so it's just easier for the viewer to see. Okay, next thing I want to do is I want to show the reader graphically what the solution set is. Well, since we've got an and compound inequality, numbers that have both the green arrow above it and the blue arrow above it are going to make both of these individual inequalities true. Therefore, they'll be the solution to the and compound inequality. I think those are these numbers right here. And now that we've done it graphically and shown a reader the solution set, now let's write out a statement of it. And I think that's d is less than or equal to 2. I find it easier to find the solution set with the graph first and then to write out the statement. That's just me. And that's going to be the general kind of strategy that we use. And so while we're going to do some more and walk through them now, if you feel like you're ready to try them on your own, feel free to pause the video and then play it later to see how it went. So no different here. The first thing we're going to do is solve this guy individually and then solve this guy individually. So for negative 3w plus 17 is less than or equal to 29, let's subtract 17 from both sides. We end up with negative 3w is less than or equal to 12. When we divide by negative 3, definitely want to remember that that inequality sign is going to flip directions. I'm going to write that first. So we've got w is greater than or equal to negative 4. All right, first inequality solved. With this inequality on the right, let's start by adding w to both sides. Adding w, 6w minus 13 is greater than or equal to negative 9. Awesome, let's add 13 to both sides. 6w is greater than or equal to 4. And when we divide by 6, we're going to get w equals, or rather is greater than or equal to 4 over 6, also known as 2/3. Boom! And now we're left with the compound inequality. W is greater than or equal to negative 4, or w is greater than or equal to 2/3. And well, we know how to do that. So let's graph this one first in blue. So negative 4 is going to be our boundary number, and that's going to be filled in, negative 4. A nice long arrow. W is greater than or equal to 2/3. All right, here's 2/3, our boundary number. with another nice long arrow, but just above the other one, making it very easy for the reader to see. Since this is an OR compound inequality, if you make one of these true or both of these true, heck, if you make any of them true, you're going to be a solution. So the only numbers that aren't solutions are these guys out here because they don't have blue arrows or green arrows above them. So what's the solution set graphically? I think it's all these numbers that are greater than or equal to -4. So let's go ahead and write that solution set. Awesome. So hopefully we're getting the hang of this. Let's try some more. All right, so let's take care of some more examples. The strategy doesn't change at all. I'd say the real theme here is there's so many steps that go into solving these compound inequalities that it's all about being super duper accurate with all of our steps and make sure we don't make a mistake in the beginning that cascades all the way down through the end. Okay, here we go. So for this first inequality, I'm going to collect my g's on the left side of that inequality. So let's add 5g to both sides, yielding the new inequality 6 plus 7g is less than or equal to 27. We go ahead and subtract this 6. 7g is less than or equal to 21, dividing by 7. So we end up with the simplified inequality g is less than or equal to 3. Phenomenal. Let's take care of this individual inequality. I'm going to collect my g's on the right-hand side now. So I'm going to add 2g to both sides. We've got -3 is less than 6g minus 45. Let's go ahead and add that 45 to both sides, yielding our nice simplified inequality of 42 is less than 6g. One more step, dividing by 6 yields 7 is less than g. Okay, so again, we've solved each of them individually. Let's go ahead and graph them on the number line. So g is less than or equal to 3. So 3 is our boundary number. It is filled in. And let's make a nice long arrow to the left. Awesome. Our other inequality is 7 is less than g. It's the same thing as saying g is greater than 7. So here's our boundary number, not filled in. This arrow is going to go to the right. Now I tell myself, okay, is this an and or is it an or compound inequality? It's an and compound inequality, so in order to be a solution, the numbers are going to have a blue arrow above it and a green arrow above it, and you know what? There is no number, and so this compound inequality has no solutions. And so that might not have been so clear when we looked at our original problem, but after doing all these steps and graphing it on a number line, it is clear that no number is going to ever make this statement true and this statement true at the same time. Alas. All right, again, if you feel like you're comfortable with these problems, I urge you to try them on your own, and I'm going to walk you through anyway, but just a good opportunity to see how well you know the material. Okay, here we go. All right, for the next one, the strategy is no different. Let's start by solving this individual inequality, and I'm going to collect my b's on the left-hand side. In general, I like to isolate my b's on whichever side of the equation is going to leave me with a positive number of them, because if I have a positive number of b's, it is much less likely that I forget to flip the direction of the inequality when dividing by a negative number. So, just a thought. Here we go. We end up with 2b is greater than, or nope, just greater than -3. And so we end up with our simplified inequality. B is greater than -3/2. Awesome. If we make our way to the right inequality, I'm going to subtract a b here. So we've got 8b plus 5 is less than 1. Let's subtract 5. We got 8b is less than -4. Dividing by 8, we end up with our simplified inequality. B is less than -4/8, or that reduces to -1/2. So here we go. So let's graph these individually on the number line. So we got b is greater than -3/2. So -3/2 is our boundary. Open circle, a nice long arrow to the right. B is less than -1/2. -1/2 is going to be to the right of -3/2. Open circle, nice long arrow to the left. Okay, is this an and or is it an or compound inequality? It's an or compound inequality. So in order to be a solution, the number is going to have at least one arrow above it. You know, if it's got a blue arrow above it, you're good. If it's got a green arrow above it, you're good. If it's got both, you're good. And in fact, I think every single number has at least one arrow above it. So the solution set here is going to be all real numbers. And that might not have been so clear before when we looked at the original problem, but graphing them and, solving them and graphing them on the number line made it very clear that no matter what real number you choose, it will make either this true, or maybe even both. Okay, one more type of problem that I want to discuss before we're done here. All right, the last type of inequality that I want us to explore today is what happens when you have an inequality that's kind of one of these longer, complex inequalities that can be sometimes difficult to navigate. So there are two different ways that I like to handle these types of inequalities. So we're going to solve the exact same problem in two different ways. And so I read this as 12 is less than or equal to negative 3q plus 4, which is also less than 28. And when I look at this, I actually see two inequalities at the same time. The first inequality is 12 is less than or equal to negative 3q plus 4. And so I'm going to kind of write that off to the side over here. 12 is less than or equal to negative 3q plus 4. But also, I noticed that negative 3q plus 4 has got to be less than 28. So I also see the inequality negative 3q plus 4 is less than 28. So I'm going to kind of toss that over here. Negative 3q plus 4 is less than 28. Awesome. And my other claim is that in order for this big statement to be true, negative 3q plus 4 has got to be greater than 12, but also at the same time it's got to be less than 28. And so this compound inequality is going to be an and compound inequality. And so if you're ever faced with one of these longer, complex inequality statements, this is one strategy you can employ. Split it into two individual inequalities, which will be separated by an and statement. So now let's go ahead and quickly solve them both. And I think the steps are going to be exactly the same, which is going to come up later. So in the first, I think we're going to subtract 4 from both sides, yielding 8 is less than or equal to negative 3q. And when we divide by negative 3, definitely just want to remember that that inequality is going to flip directions. And we end up with q is less than negative 8/3, or negative 8/3 is greater than or equal to q. On the right-hand side, the steps are going to be exactly the same, right? Just like we subtracted 4 as our first step up here, we're going to subtract 4 as our first step up here. Negative 3q is less than 24. Then, just like we divided by negative 3 before, we're going to divide by negative 3 now. So divide by negative 3. The inequality switches directions again. We end up with q is greater than negative 8. Okay, now let's graph each of these individually on the number line. So the first one we're going to do is negative 8/3 is greater than or equal to q, or q is less than or equal to negative 8/3. So negative 8/3, it's a filled in circle, and we are going to make a nice long arrow to the left. Our other inequality is q is greater than negative 8, so there's our boundary number, an open circle, and we are going to shade to the right. Since this is an and compound inequality, we need our numbers to make both this statement true and this statement true at the same time. It needs to have both a green arrow and a blue arrow above it, and those are these numbers right in the middle. All those numbers starting at negative 8/3 and ending at negative 8, but not including negative 8. And so our solution set here, we are going to also write in a kind of complex way. Remember, we talked about this before. We would write that solution statement as negative 8 is less than q, which is less than or equal to negative 8/3. And I'll give you a hint that when you are given a long, complex inequality like this to solve, pretty much every time your eventual solution set is going to also be one of these kind of complex inequalities. Okay, so one thing I made note of as we were going through that problem was once we split these up, the steps were exactly the same. We subtracted 4 from both sides, then we divided both sides by negative 3. So the other strategy that some people employ is they know that there are two inequalities happening here. We've got 12 is less than or equal to negative 3q plus 4, and negative 3q plus 4 is less than 28. But since they know the steps are going to be exactly the same, subtracting 4 and dividing by negative 3, they kind of handle them both at the same time. And this is what it looks like. They actually don't split this up at all, and you can, for instance, subtract 4. And it's kind of odd because it'll look like this. We subtract 4 from kind of the middle and the right and the left. I mean, it's not like both sides of an equation or inequality kind of thing anymore. It's like you're doing this inequality and this inequality at the same time. I don't know how else to explain it. So we end up with a new complex inequality. 8 is less than or equal to negative 3q, which is less than 24. And so it's kind of like we've got this step and this step kind of combined into one right here. And then just like we divided by negative 3 before, we divide by negative 3 now. We're of course going to divide negative 3q by negative 3, but we're also going to divide 24 by negative 3, and we're also going to divide 8 by negative 3, and whenever you divide by a negative number, those inequalities are going to switch directions because, well, That's what happens when you divide by a negative number. And so we end up with this statement. We've got our q, and we've got our negative 8/3 is greater than or equal to q, which is greater than or equal to negative 8. By convention, we really prefer to write our inequality going from left to right on the number line. So I'm going to quickly rewrite that as negative 8 is less than or equal to q is less than or equal to negative 8/3. And then, you know what you can do? You can just, if you know this is your solution set, you're welcome to kind of split this up and draw these two individual inequalities, but you can also say, listen, our solutions are all numbers between, oops, excuse me, this is not supposed to be or equal to, sorry. You can say our solution set is going to be all numbers between negative 8 and negative 8/3, including negative 8/3, and not including negative 8. And you can simply go right to the graphing stage and say, all right, negative 8, negative 8/3, boom, here is our solution set. So 2 different ways to handle the exact same problem, and you are welcome to use whichever you like. So I hope you found this helpful, and I hope you enjoy.